All right, so the last project on Tinkercad, which is using an LCD. Now, since we don't have all the parts, when you guys finally move to the actual hardware build, you're not going to be completing every project listed here. But again, press control on your keypad and click on this, and that should open this web page. Now, we're going to create this project with an LCD screen, which is going to say Hello World. Parts we're going to need is the LCD display, potentiometer, and 16 jumper wires. Now, the LCD, which is the liquid crystal display, are designed to show a grid of letters, numbers, and a few special characters. We're going to be using the one which is the 16 by 2, that is 32 characters of information. The potentiometer is basically going to be used for contrast. All right, and the pixels are going to look somewhat like this. All right, so here we're going to follow this. So we're going to need our breadboard over here, Arduino board, potentiometer, and our LCD. So we're going to click on Create Circuits. All right, so R to rotate this potentiometer, and then our LCD. As you can see, we have the 16 by 2, and then we have the 16 by 2 I2C. We're not going to be using that one. We're just going to be using this one right over here. All right, so now let's see. All right, so let's turn this around this way. Again, you could switch it however you want. I'm just thinking now these holes. So as you can see, this is GND, VCC. If you can see, there you go. Let me zoom in. All right, I'm going to make sure that they actually align. So GND is going to align to this right here when I snap it on. You can see it snaps on. Oops, I created a Y by mistake. Take it off. Now you can connect it that way by just snapping it on, or you can connect a wire and then connect it this way. That's also one way of doing it, but I'm going to delete that and I'm going to do it this way. All right, just similar to kind of what they did over here, the snap on. All right, so as we can see for the potentiometer, we have two wires. One's connected to the GND and the other one is connected to the 5 volts. So I'm going to do these two connections over here from 5 volt GND on the Arduino board to the breadboard, and then from the breadboard connect to the potentiometer. All right. Now, let me move my potentiometer over here. So we have our 5 volts. And let's bring that over here. And red. And then GND. Again, it doesn't matter which GND that you use. And let's connect that over here. And that's going to be the black one. All right, now why don't we put our potentiometer right here, right? Or let me actually put it here so it doesn't come in the way of the connections that I'm going to be making over here. So let me just put it right over here, and one is going to go to GND, the other one is going to go to this one, and that's going to be the red, just to be consistent right there. Okay, now the next, as you can see over here, now to help you to determine, because this LCD 16 by 2 does not have any write-ins on there, so it's like, which one are you connecting, all right? But we're just going to look at it from this point of view. So if you, let's just say this side of the LCD is going to be this side over here, right here, if you get what I'm saying. So this side, because it's closer to where it basically ends, over to this side. And as we can tell, the very first one is the black wire, which is connected to the GND, and then the next one is the 5 volt, which is connected to that. And if you look at it, GND and VCC, yep. So we're going to connect this. Let me trying to see if I want to do it straight, and I could probably do it straight. So I will connect it this one. I already have red, so I'll start with VCC and I'll connect it here, and then I'll connect the next one right here, and this one is going to be the black, and then I'll connect this one. I'll connect it right here. I try not to go diagonal. I just want everything to be kind of pretty clear and clean. All right, and then this one goes to red right over here. All right, so we got these two connected. Now let's okay, so this is the end. Okay, so I'm starting from here. The next third one goes to the potentiometer. That is the middle of the potentiometer. So that would be this one right here. And I'm gonna try and do it like this. As much as I try to not let's see, maybe I'll go behind it. No, maybe I'll just do this. Hopefully, let's just do it that way. And let's make it blue. All right, so as you can see, that goes to the middle part of the potentiometer. All right, so after that, there's this purple looking one, and that goes to pin number 13. Pin number 13. So that would be this right here. And let's see. Maybe I'm just going to have to do it this way instead. Uh, this way and this way, and then pin number 13. What color is that? Oh yeah, it's purple. All right. All right, so that goes to pin number 13. Take note of that. There's a lot of wires over here. The next pin goes to ground again, so that'll be here, and that goes to ground. Now it doesn't really matter because this one is going to be easier to connect, and that goes to ground. All right, then the next one, the light blue or turquoise, goes to 12. So that would be this one right here. And let's see. Turquoise. All right. All right. So basically, I've completed over here. Now, once you're done, you could easily just skip how many pinholes or count how many pinholes you have to skip, or you could just start from the end over here, which is GND and then most likely VCC. Okay, so all right, so it doesn't start that way. It's labeled a little different, but I know that the very first one is GND. So this one, I'm gonna connect it right here, and this is going to be black, and then this goes to GND, and then the next one, that's red, goes to positive. All right, then the next one, the blue one, goes to pin number 8. So that would be this one right here. Goes to pin number 8. All right, and then the green one goes to pin number 9. So that's the next one. That'll be this one. I'll just connect that straight. All right, let's see. What color is that? I believe that's green. And then the next one is yellow. Yellow 10, and then the next one is 11. All right. So this one, whoops, sorry, I made a mistake. Oh man, this one right here goes to pin number 10, and let's make that yellow. And then the next one goes to, I believe, pin number 11, and I think that one is the white one. All right, so hopefully that is clear. Let me just zoom in, and you can definitely um, see it better. So you can pause it here to look at it much better. as you can see right here. Let me just go up a little bit. Okay, there you go. So you have everything and you know where they're connected. As you can see, this LED is the black, this other LED is this. All right. um, Now this, so I think basically we're done with this over here, so I'm just going to go back now. The problem with this again is that this is an one uh, old tutorial. It does not have a resistor, so I believe if I'm right, so let's actually get the code. Let's scroll down, copy code, and Control 8, delete everything, paste code, start simulation, and hopefully it works. Okay, it's more of an internet problem, so let's start over again. Let's try again. Sometimes you do experience. Okay, as you can see, it works now. But you can see right here, it says current through backlight LED is 23.7 kiloamps, while maximum is 20 milliamps. So there's a problem over there, right? So you're going to have or get this, right? Now it doesn't tell you in the tutorial, but in order to fix it, if I remember right, so let's stop the simulation. If you guys remember when we learned about resistors, right? So why not, let's say this is 330 ohm resistor, and we are going to, so let's remove this wire right here, and this wire is going to be our resistor connecting from this part to this next part. So we're just going to delete it, and we're going to put our resistor here instead. So now it's going through a resistor. Now let's try this again. Well, still same problem, and I think I'm trying to remember right. I think I actually plugged it in the wrong place. Let's see. Well, I think it's actually this one right here. Let me delete. And I think it was actually this one. Now let's try it again. Nope, and it's still not working. Which one? What mistake am I making? Let's see. All right, so let's go back. I think it might be actually this one. Let's see if it's this one. Let's start. There we go. Yes, so it was this one. All right, so now it's working, so we don't have too much. Um, and sorry, I didn't think about it as I'm thinking about it now. Um, this is going to the LED, so it would make sense. So this is the cathode, this is the anode. So definitely it would make sense that it would be this that I should have actually used in the first place. Um, let's see if there's any documentation, if they provide any documentation in regards to that. Um, in regards to which one is the backlight. All right, so not necessarily, I don't think I see it right now. Okay, so let's see, ground VDD. So it does say pin number. Okay, there we go. All right, so okay, there you go, right here. As you can see right here, it tells you right here that this is basically the power, the backlight power. So 15 and 16, that's the backlight power, and that's what basically I ended up doing. So instead of I made a mistake when I put it here, it should have gone over here, because initially the problem it said was that there was too much power current going through the backlight. So this was the right one. That's where. So again, the resistor goes over here and it should work, and this is for contrast. As you can see, it goes off, and then if I turn it on, there you go, and I think I broke it. Sometimes the simulation is not the best, but let me see. But it should still work. I'm not sure why it just all of a sudden just broke. Okay, there we go. All right. All right, take care.